So long division is one of those things that it sure would be nice if there was a shorter, more, I don't know, less complicated way to do it. And sure enough, there is. And it has a weird name called synthetic division, which makes some people think that it's actually the name scares them. But it's actually a simplification of long division. But being a shortcut, it actually has a few restrictions. First thing is it only works with linear divisors, right? Divisor meaning the thing I'm dividing by. So notice that both of these have an exponent of 1, okay? Both the dividend and divisor must be in standard form. That's nothing new. And all missing terms must be rewritten with a 0. Nothing new. That's really important to understand both those things, okay? If the divisor has a coefficient other than 1, you have to, you must divide the quotient by the divisor's coefficient. What that is saying is there's a problem when you have like a number in front of the x. So the first two examples don't have that, and then we'll look at problems. So let's learn the process. So the process is, and what makes long division difficult is the fact that you have to subtract a lot. That's actually the place that students make errors. So what somebody thought up before we had calculators and before we had the internet a long time ago, what happened is they figured if they set the divisor equal to 0 and solve, right? If I solve that, I would get x is equal to 2. And if I use that number instead of this number, I don't have to subtract, I can now add. And so to denote this differently, they flipped the division symbol upside down. And to make it even easier, they got rid of the variables and just used the coefficient. So here they just used the coefficient of 1. So they put a 1 right here. Here they use 3. And here they use -5. And some teachers and students will actually label this column as the quadratic column, the x column, and then the constant column. That's very helpful. And so what you do is inside this inverted synthetic division box, you add everything that you have in here. So you start from left to right. 1 plus nothing is 1. And then just like regular division, you multiply. 2 times 1 is going to give you 2. And then you add. 3 times 2 is 5. And then you multiply. 2 times 5 is equal to 10, and then you add -5 and 10, which gives you positive 5. So what is the answer? So the answer comes out also with no variables on it. So what happens when you divide is you reduce this column by 1 exponent for the answer. So if this is a square, this will be the x in the answer. And if this is an x, this will be the constant in the answer. And if this is the constant, this will be the remainder in the answer. So the answer comes out as 1x, this is the quotient, 1x plus 5, and then plus 5, and it's a remainder, so same rules. The remainder will be this number and then divided by the divisor. And I don't know if you realized it, but we actually just did the exact same question we did with long division. So let's see if we got the same answer. X plus 5 over x minus 2. And if I go back to the problems we just did, right here, same problem, look what we got. X plus 5 over x minus 2. My advice, this process is very easy, but because it's so devoid of letters, students really need to see it again. So I would pause that video, I'd go back a couple of minutes, and I would watch that again. So let's take a look at the next example. So the next example, again, here's the process. We set the divisor equal to 0, which would give us x is equal to -1. We then put that -1 on the outside of the divisor symbol, the division symbol, which is now inverted. We take the coefficients of this, but we have to be careful about this rule. It has to be in standard form, and if you're missing a term, you have to put a 0 there. Students do a really good job with that when they do long division, but for some reason when they come in here, it's like they don't see the fact that we're actually missing a 0x right here, right? Sorry, 0x squared. So when I label this out, I want to start with the fact that I have a cube, and that's why labeling this helps. And you want to have something for each column for the entire polynomial, even if that column is actually a 0. So in this problem, I have a 1 for the cube column. I have a 0 for the quadratic column. I have a 3 for the linear column, and I have a -5 for the constant column. Inside the box, we are going to add. So 1 plus nothing is 1. -1 times 1 equals -1. 0 plus -1 is -1. -1 times -1 is +1. 3 plus 1 is 4. -1 times -4 is -4. -5 and -4 add to -9. To figure out the answer, you reduce this column by one exponent. So this in the answer is x squared. This is the linear. This is the constant. This is the remainder. So the actual quotient is 1x squared minus x plus 4 minus the remainder of 9 over the divisor, which is x plus 1. So it's almost like you're doing this in code, and once you learn the code, it makes division much easier. But there is an important caveat right here about what happens if I stick a number right there. So let's take a look at what happens on that. And by the way, this problem is impossible because of this, and I'll talk about that in a minute, but you can already see that. So let's take a look at this one. This one, when I set it equal to 0, I don't end up getting, I don't have an integer. I have a, right, I'm going to subtract 1. So I would have, I'll just do it right here. 2x plus 1 is equal to 0. So let me actually show you what we get before I start talking about it. So we would subtract 1 on both sides. We get -1, and then we divide by 2. So we end up getting -1. That, of course, is a rational number. Many people call it a fraction, and that's where the problem lies. It's not impossible. We just have to be careful what that means. So we take -1/2. We draw our inverted division symbol. It looks like we have a cube, so I'm going to label that I need to have a cube. I need to have a square. I need to have an x. I need to have a constant. I have a 2 for my cube. I have a 9 for my square. I have a 14 for my x. I have a 5 for my constant. So I'm going to add inside the box. 2 plus nothing is 2. And then don't get afraid. I'm not going to provide a fraction that's complicated. -1/2 times 2 is -1. 9 plus -1 is 8. So you can see what I did here where I gave you an example where the fraction plays nicely. So that's not the problem. -1/2 of 8 is -4. Add this together, and that'll give you 10. And then multiply half of 10 negative, that will give you -5. And then 5 plus -5 is 0, which means I have no remainder. So then you label this by starting with the cube and saying the answer is reduced by 1, x squared. This will be reduced by 1, so x. This reduces by 1, so constant. This is remainder. So your answer comes out to the quotient, at least you think the quotient is, it is 2x squared plus 8x plus 10. And this answer is actually off by a factor of, guess what, 2. So you got to think about this as saying you need to divide the answer by 2. It's always going to be that way. And let me show you how obvious it is. If I try to take 2x and make it become 2x cubed using long division, what do I need to multiply this by to get this? I don't need the 2, but it's in my answer because the 2 is already there. So you just have to remember, if you have a fraction for long division, you have to come back and divide by the denominator. You don't care about the negative or the 1. You just care about the denominator. And the real answer is actually x squared plus 4x plus 5. That's the real answer. It has to be reduced by the denominator. And then the last really important part is this. If you have a divisor that is quadratic or higher, you can't do it. You have to go back now, unfortunately. You're going to have to do long division. You're going to need to make sure you put that placeholder for the linear term in there. You're going to need to make sure you do the entire thing. This is very important for later in the polynomial chapter because division is extremely useful for reducing problems, but you can't use the shortcut synthetic division method on a quadratic. So you have to do this using long division. Okay, so just remember that. Synthetic division is great, but it only works when the coefficient has an exponent of 1.